Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. My name is Zafwan from the MT3 class. Today I would like to present my study title, Vectors, Analysis and Navigation, which is Helicopter and Drone Case Study. Vectors are very important in mathematics, especially when we want to describe motion. In many real-world situations, objects do not move in only with speeds, but also with direction. Because of that, we need vectors to represent both magnitude and also direction accurately. In modern terminology, vector mathematics is widely used in many systems such as GPS navigation, aviation, maritime transportation, and also autonomous vehicles. These technologies rely on vector calculation to determine movements, predict positions, and avoid collision. In this presentation, I will explain how vector analysis can be applied to a real-life scenario involving a rescue helicopter and a medical drone. Both vehicles need to travel to the same destination while dealing with environmental factors such as wind and also obstacles. Through this case study, we will see how mathematical concepts such as vector equation, parametric equation, unit vector, and also dot product help us to analyze motion and also ensure the safe navigation. First, let's take a look to the introduction of this study. Vector analysis is a fundamental mathematical tool that help us to represent quantities that have both magnitude and also direction. This concept commonly used in physics, engineering, and also aviation. In a three-dimensional environment, such as airspace, aircraft movement cannot be represented using simple numbers. Instead, we use three-dimensional vectors to describe their trajectories. Vectors can be expressed using different mathematical forms, such as parametric equation and symmetrical equation, which is help us model the path of moving objects. In a real-world situation, many external forces can affect the motion. For example, wind, gravity, and air resistance can change the direction or speed of the aircraft or drone. Therefore, mathematical models are needed to predict these effects. In this study, we analyze a scenario involving a rescue helicopter and also autonomous medical drones. Both vehicles are traveling to the same location, but they avoid obstacles and deal with the environment disturbance. Using vector calculation such as dot product and vector magnitude, we can determine possible collision risks and analyze how wind affect the flight path of the drones. This shows how mathematics plays a very important role in ensuring safe and efficient navigation system during navigation. Let's take a look to the learning objective of this study. The first objective is to apply three-dimensional vectors analysis in solving real-world navigation problems. Instead of learning vectors only in theory, this study shows how vectors can be used in a real-life situation. The second objective is to determine the trajectory and also the direction of the motion of a rescue helicopter and also autonomous drone using vector equation. By using vector, we can clearly represent how this vehicle moves in space. The third objective is to analyze the impact external forces, especially crosswind on the drone flight path. Wind can change the direction of movement, so vector calculation help us to determine the new direction. And the fourth objective is to evaluate the potential collision risk between the drones and the telecommunication tower. By analyzing these coordinates and vectors, we can predict whether the drones might collide with the obstacles. Finally, the studies aim to demonstrate the importance of vector mathematics in improving navigation accuracy, safety, and efficiency in a modern transportation system. Overall, this objective shows that vectors analysis is not just a theoretical concept but a practical tool used in many modern technologies nowadays. In this project, I have concluded three types of application in vectors. First of all, for this slide, I will explain about how vector in mathematics is used in GPS tracking system. GPS, or Global Positioning System, work by receiving signals from multiple satellites orbiting the Earth. Each satellite sends a signal containing information about its position at the time the signal was transmitted. When GPS receiver, such as a smartphone or navigation device, receive signals from several satellites, it calculates its position by measuring the distance from each satellite. This distance can be represented mathematically as a vector. In the vector form, the magnitude of the vector is represented by the distance between the satellite and the receiver, while the direction represented by the orientation of the signal in three-dimensional space. By combining the several vectors from the different satellites, the system can determine the exact location of the receiver. This process, known as triangulation or trilateration. Vector analysis is especially important in complex environments. For example, in large city with tall buildings, satellite signals may be blocked or reflected. These reflections are known as multipath signals and they can cause error in positioning. However, vector-based algorithm help reduce this error by analyzing the direction and strength of signals. This allows the GPS system to estimate the correct position even when signals are partially blocked. In addition, vector mathematics is also used in determining velocity and direction of movement. For example, when you use a navigation apps in your car, the system calculates your movement vector and to determine your speed and direction. According to research by So and his colleagues, vector-based positioning methods help improve accuracy GPS system, especially in difficult environments such as urban area and also indoor location. Therefore, vector analysis plays a crucial role in ensuring the GPS system remain reliable and accurate in everyday navigation. Next, I will explain how vectors are used in maritime navigation. When ship travels in the ocean, the movement is influenced by several vectors. These include the ship engine's power, wind direction, and also ocean currents. Each of these forces can be represented as a vector because they all have both magnitude and also direction. For example, the ship engine produces a vector that represents the intended direction and the speed of the ship. However, ocean currents may push the ship sideways and the wind push it in another direction. To determine the ship's actual path, we use vector addition. This means we combine the vector of the ship's velocity, the ocean currents, and also the wind. So the result of this vector addition is called as the resultant vector, which represent the true direction and speed of the ship's movement. Without this calculation, ship could easily drift away from their planned routes. In the modern maritime system, vector data is analyzed using advanced technologies such as artificial intelligence and machine learning models. For an example, bidirectional long short-term memory networks are used in analyze historical vector data including ship movement, wind pattern, and also ocean current. This system can predict the future position of the ship based on the previous moving pattern. This technology is very, very important and also crucial for the preventing collision between the ship, especially when busy shipping lanes. It also helps to optimize the travel routes so that ship can choose the most efficient path, which reduce the fuel consumption and also travel time. Therefore, vector mathematics is an essential tool in maritime transportation, helping ensure both safety and efficiency in the global shipping operation. Aduh, dah rambut dan kau. Now I will explain how vector are used in unmanned aerial vehicle or UAV, which is commonly known as drone. Drones operate in 3-dimensional space, which is mean their movement involve 3 direction: forward, backward, left or right, up or down. To control this movement accurately, drones rely heavily on a vector calculation. Each movement of drones can be represented as a vector that describes its speed and also direction and also altitude. One important concept used in drone navigation is called the wine triangle method. The wine triangle combines 3 vectors: the drone's airspeed vectors, the wine vectors, and also the ground speed vectors. The airspeed vectors represent the drone's movement relative to the air. However, when wine is present, it pushes the drone in the different direction. By adding the airspeed, the vector of the wine vector together, we obtain the resultant vector, which is represent the drone's actual movement relative to the ground. This calculation helps drones to maintain their correct flight path even when strong winds are present. In another important concept is vector field. Vector fields act like an invisible pathway that guide the drones along a specific route. This field contains directional information that tells the drone where it should move at a very point in space. Using sensor and onboard computer, the drone continuously analyze this vector field to obtain the stable flight and avoid obstacles. For example, if the drone detect an obstacle such as building or tower, it can automatically adjust its direction vector to move around the obstacle safely. According to research by Wilhelm and Kram, vector field navigation allows drones to perform complex tasks such as autonomous delivery and also search and rescue operation. Therefore, vector mathematics plays a very important role in enabling drones to fly accurately, safely, efficiently, even in challenging environmental conditions. Now I will explain the problem scenario used in this time. In this situation, a rescue helicopter is delivering emergency supplies to a mountain peak. At the same time, an autonomous medical drone is launched from a base station to deliver medicine to same location. However, there are 2 challenges in this scenario. The first challenge is the presence of strong crosswind that can affect the drone's direction. The second challenge is a telecommunication tower located near the flight path. Because of this obstacle, we need to analyze the trajectories of both helicopter and drones carefully to ensure that there are no collision happen. Vector analysis will help us to understand and solve this problem. So, this slide shows the important data used in this case study. The helicopter travels from the base to the mountain peak with the coordinate of 25, 30 and 48 and 4. Meanwhile, the drone has an initial velocity vector represented by 10i, 12j and 2k. There is also crosswind represented by the vector negative 2i plus 3k. Finally, the telecommunication tower is located at the coordinate 32, 60 and 8. Using this information, we can apply vector equation to analyze the movement of the helicopter and also drone. Next, we determine the direction vector of the helicopter. The helicopter travels from the point P with coordinate 5, 10, 0 to point Q with coordinate with 25, 30, and also 4. To find the direction vector, we must first subtract the starting point from the ending point. For the x-axis, we can calculate 25 minus 5, which is equals to 20. For the y-axis, 30 minus 10 equals to 20. For z-axis, 4 minus 0 equals to 4. Therefore, the direction vector of the helicopter is 20i plus 20j plus 4k. This vector shows the direction in which the helicopter is traveling. After finding the direction vector, we can construct the vector equation of the helicopter's path. The starting point vector is 5i plus 10j and plus 0k. Using the vector equation formula, we combine the starting position with the direction vector. So the equation becomes r equals the position vector plus t times the direction vector. Therefore, the final vector equation is r equals to 5i plus 10j plus t multiplied by 20i plus 20j plus 4k. This equation represents the helicopter's trajectory in a three-dimensional space. Now, we determine the parametric equation of the drone path. The drone's velocity vector is 10i plus 12j plus 2k. From this vector, we can construct the parametric equation for x, y, z coordinates. Each coordinate changes over time based on the component of the velocity vector. This parametric equation allows us to calculate the position of drone at a given time. This is useful when analyzing drone's movement and determine whether it will reach a specific location. Next, we calculate the unit vector in direction of the helicopter. A unit vector is a vector with a magnitude of 1, represent only the direction of motion without considering the magnitude. To find the unit vector, we divide the direction vector by its magnitude. First, we calculate the magnitude using the square roots of the sum of square of the components. After finding the magnitude, we divide each component of the direction vector by this value. The result is the unit vector that represents the exact direction of the helicopter movement. In these steps, we determine the coordinate of drones when its altitude is equals to 5. Using the parametric equation, we set the z value is equals to 5. Then we solve the equation to find the value of time, which is t equals to 2.5. After finding the value of t, we substitute it back into the equation for x and y. By doing this, we can calculate the exact position of the drone at that altitude. This is help us to understand the drone's location during its flight.
Ya Allah, 49 minit je.
Now, we analyze how the crosswind changes the drone's directions. To do this, we use the dot product formula to find the angle between two vectors. The first vectors represent the original velocity of the drone, while the second vectors represent the new resultant velocity after the wind effect. First, we can calculate the dot product of the two vectors. Then we can calculate the magnitude of each vector. Next, we substitute this value into the cosine formula. Finally, we can apply the inverse cosine function to find the angle between two vectors. This angle shows how much the drone's direction has changed because of the wind. So now we are heading to discuss about the importance of vectors. Vectors are extremely important in many real-life applications. First, vector can help to determine the direction and the magnitude of motion for moving objects. Second, they improve the accuracy of navigation system used in aviation, maritime transport, and autonomous vehicles. Vectors also can help engineers analyze environmental forces such as wind and also ocean currents. In addition, vectors analysis allow us to predict movement and potential collision risk. Because of these advantages, vectors are widely used in technologies such as a GPS system, drones, and autonomous vehicle, like what we already discussed now. In conclusion, so we can conclude that vectors analysis play a crucial role in modern navigation system. Through these studies, we can see that vectors mathematics allow us to model and analyze real-life movement accurately by computing the direction vectors, parametric equation, and resultant vectors, so we can understand how external forces affect the movement of vehicles. Vectors analysis also help predict potential risks such as collision with obstacles. Therefore, mastering vector algebra is essential for engineers, scientists, and navigators who work with modern transportation technologies nowadays. Ideal Fitri. Not to forget to answer all three essential questions. First one, how can mathematical tools be applied to model and interpret real life situation? So for this question, mathematical tools help us model real life situation by representing them using numbers, formulas, and equation. In many real world problems, situation can be complex and difficult to analyze. So therefore, mathematics allows us to simplify this situation into mathematical models. For example, in this case study, we use vector equation to represent the movement of helicopter and drones in three-dimensional space. By using vectors, we can describe both direction and magnitude of motion accurately. So mathematical tools also allow us to predict outcomes. For instance, by calculating direction, vectors, and position, we can determine where an aircraft or drone will be at a certain time. Therefore, mathematics helps transform real-life situation into structured models that are easier to analyze and to be understood. So for the second question, how do mathematical methods support decision making? By identifying the solution under given constraint. So for me, mathematical methods support decision making by helping us analyze different possible outcomes and choose the best solution. In a real life situation, in a real life situation, we often face constraints such as time, distance, environmental condition, or safety limits. So using mathematical calculation, we can compare different options and determine which is one will given us the best and the most efficient result. For example, in our vector navigation problem, we analyze the drone's flight path and effect of the crosswind by calculating the direction and angle of deviation. We can determine whether the drone path is safe or not, whether needs to change direction or not. This kind of analysis help engineers and pilots to make better decision before a problem occurs, which can improve the safety and also efficiency. So mathematical methods are very useful for identifying optimal solution within the constraint. So the third and last question, which is why mathematics are powerful tools for analyzing challenges across the different contexts. For me, mathematics is a powerful tool because it provides logical and systematic ways to solve problems. Many real life challenges involve pattern, measurement, and relationship between different variables. Mathematics help us analyze this relationship clearly. For examples, vector mathematics is used not only aviation but in GPS system, maritime aviation, robotic and also autonomous vehicle. By applying mathematical concept, we can predict movement, analyze risk and also design the system to operate safely and efficiently. In addition, mathematics allows solution to be applied in many different fields, including engineering, technology, economic and science. Because of this versatility, mathematics play important roles in solving complex problems and improving modern technology system.